Okay, trying to figure out where I left off at. The last thing I left off at was, well, I know I haven't talked about any of this stuff here. This was what I was looking at before class. Yeah, we had not got into 5. Okay, sooner or later I'll find where we were at here. We were in the chapter 3, as I recall, yeah. All right. The last thing we kind of talked about was we discussed the if statement. Actually, we had not talked about the if statement yet. The last thing we talked about was the craps roller program right there. Right there. We talked about that there. And then, of course, we talked about the random function. The password one I'm going to skip right there. Basically, that's just enter your password. If the password is equal to a certain thing out there. The if statement works exactly like what we've seen before. If, now the one thing to keep in mind is that, and I forgot about this at the beginning, is that at the end of our if, we have to put a colon right there. That little colon is just part of the syntax right there. And then remember that there is no end if right there. The end if is the end of the indentation. So everything that's indented here is part of the if clause right there. So this particular program, all it does is, welcome to Security System Inc., but where security is our middle name, which stupid slogan. Passport is equal to input. Enter your passport. If the password is equal to secret, big, that there. Then print grant access granted. Input that's just to end the program right there. So, right there. The whole thing discussed there is that the if is the key right there, and we're going to say if, and it's really hard to see here in this text, but in reality, and I just put my finger on the screen, so therefore my pen stopped working. Right here. It's really hard to see, but right here, that's actually an equal right there. That there, I don't know if you can see that looking at the screen, but that's equal right there. And the comparison operators are right here, equal to, and this again is the equal right there. So the rest of those are the same as C, right there. That there, the only one that's different in some languages is the not equal. Every now and then is the less than or equal or greater than symbol. Though some places will use that versus not equal that there, but I think not. The exclamation mark equal is the standard right there. Right there. So one of the traps right here, and again in this book, this is actually a very good book, in my opinion. There for learning, it's a self-taught book, but I think it's a good book. That there, it's easy to understand for most of you, right? A lot of programming books are written too far up there, but this trap is an important thing here. Is Python does a different types, definite order. So there are some things here, and they give the idea 10 greater than 5, and where 5 is a string, right there, is that the program will puke on that right there. It doesn't know how to do that. Believe it or not, some languages, some versions of C will actually try that. And what it will do is compare the ASCII code of the first letter in 5 with the number 10. It doesn't give you an error. So I think most of those have been that there. So using indentations to create blocks, I've mentioned that before. In C, we did the bracket, end bracket, right there. And then everything between those brackets was a block of code. In Python, everything that's indented is that block of code right there. My personal opinion, I like the Python method better, right there. This colon at the end, I will probably forget that forever, because I don't know why they have to have that colon. It doesn't make any sense, but it's part of the if statement right there. But there, the else clause right there is when we look at our condition, it's either true or false. And again, I kind of flew through that whole discussion on conditions. You've seen conditions before. We have the else clause, and the else clause is, again, here, if it's true, this is the then clause, and I will use the phrase if then else, even though the word then has been eliminated from the language. It's not used anymore. BASIC still uses then. Fortran uses then. And my first programming language was Fortran, so forgive me if I sometimes use syntax that's completely strange, but I use the word then. Some languages here will say if, condition, then do, then, and you would have all the things you would do first. C dropped the word then out, so you don't see then there, but the else is still there. But it's the if else now. It used to be if then else right there. So if the password is equal to secret, then we're going to print access granted. Else we're going to print access denied right there. And also note that we've got the little colon after the else right there. So that there. Now at there again, this operates the same as C. The syntax is a little different, but it operates the same. The next one is the elif, and yeah, that's one of those ones that, depending on what language, they seem to take letters away. Right there. In C, they don't have. They have the else if. In other words, you would have else if, and then your if statement, and then your bracket there. Here we have the elif right there, and what it does is it looks at there, and they usually change another if statement after as part of the else right there. And the example that they give right there is that we've got 3 moods right there. So if our mood is a random number between 1 and 3 right there. So if mood is equal to 1, then we're going to print happy right there. It just prints the little happy face. Else if the mood is 2, we're going to print neutral, which is the no, know that there, that there. And then we've got the sad face right there. Mood is 3. Now, if I was dealing with my wife, we would add the 4th one, which would be angry, right? That there. So evidently we're not talking about somebody's wife or that there. Oh, that's up there. Else print illegal mood value. You must be well. All right, that would be the one that would normally show up there. Is the illegal mood value? In my opinion, it's an illegal mood value, right? She's not allowed to be angry, but she is, right there. Probably because I sat out till 1 o'clock in the morning smoking a cigar, right? Out there, and I came to bed without changing clothes, and I smelled bad. You know, usually that will invoke the angry kick in the middle of the night, right? Go change clothes and take a shower. You smell like a cigar out there. That's the illegal mood value, right? Out there. So, all right. That there. But again, the key thing here is that we've got multiple, more than one or two clauses that there. We have clause 1 is mood is equal to 1, clause 2 it's equal to 2, or 0, 0, 1, or 2, and we could daisy chain these as many as we want. We could have 15 different moods. You know, I mean, if you go to a psychologist and they want to analyze your personality, they have at least 15 different moods on a chart. I've seen these little charts where, you know, how are you feeling today? Angry, frustrated, tired, you know, that there. So we could have 15 different moods there on our, that there. So our LF is short for else if, right there. Else if, right there. I've seen else if like that there. This is the one that VHDL uses. VHDL uses the else if like this right there. So one of the things that I've commented before is that I don't memorize a particular syntax because they change. I work with too many different languages that use slightly different syntax. So when I write code, I have a lot of syntax errors typically, especially the first pass. And even when I'm teaching something like C or C++ or VHDL, or in this case Python, and I start typing code, I have syntax errors. Out there. And syntax errors are minor in the scope of life because those are easy to fix. That there. So, right there. So, an important feature of if is that once it evaluates the true, it exits the statement right there. All they're saying that there is, if I find the mood is equal to 0, I don't look for 1 and 2. So these moods that they have to be these conditions have to be exclusive of each other. You cannot have two situations. You know, an example that there is, if we got a grade right there, and I'm going to use the American grading scale of 60 or less than 60, it's an F, 60 to 70, I'm just going to say 60 to 70, it's a D, we'll say 69 right here, 59 right here. So in other words, 59 is an F, 60 is a D right there. 60 to 69 is a D, 70 to 79 is a C, 79 or 80 to 89 is a B, and 90 or above is an A, right? Right there. So that's perfectly fine because we can do if grade greater than or equal to 90, right there, print A, right? L if equal to, or that they're 80, print B, right? Right there. And we go all the way through here. Else, print F right there. Right there. So we would do check for each one of those conditions. That's perfectly fine, but then if we wanted to say check for multiple things and two things are true, and I can't think of a good example right there, then right there, we can't do that, because once we determine that it's a B, we stop looking. Is all that this is saying right there. So there, he doesn't really give an example, and I can't come up with one right there. So that's it. The next thing that we're talking about is the while loop, and the while loop will be used for the next part of the craps program. Because I gave you the craps program, and your goal is to what? Play one game of craps, right? So the next part of that is to play 5,000 games of craps. Out there, we'll talk about that on Monday. Out there, but what we're going to do is we're going to create a loop, which will then go through and repeat while a condition is true. And this is the while loop right there. You've covered while loops in C. You probably saw them out there. But this is while response not equal because. And then response is equal to input Y right there. So this is a particular program that will just keep repeating as long as a person types in the word because right there. And this is the 3-year-old response. If anybody's ever had a 3-year-old, they like to come up and ask questions. Why is the sky blue? Because. Why is the river wet? Because. And that's all this particular program does. It just keeps repeating the same question. Why? Until you tell them something other than because. Right there. Right there. So this is the century value right there. The century value is the one we're looking at right here. Is response is our variable, and as soon as it equals anything but because, it drops out of this loop right there. So a typical one for the century value might be one, let's say, keep entering, a customer's order until the customer's orders item -1 right there. And there's right there. So here's another one, a simple right there. This happens to be an infinite loop, and the reason it's infinite is that counter is never changed. So it says counter is equal to 0, while counter is less than or equal to 10, print counter. And there's nothing that changes counter. We don't have a counter minus right there. And that's C syntax. But right there. You don't have that in there. So typically, you have to make sure that your century value variable changes on your while loop. Now, that's not always true. When we're dealing with systems with hardware, we may have systems that we want them to be infinite loops right there. So here we've got avoiding infinite loops. In most cases, you want to avoid an infinite loop. There are cases where I've wrote infinite loops right there. An example of an infinite loop would be one where I have a gasoline pump. So the first thing I do is check setup right there. If it goes into setup, right there, we call our setup routine, and then we wait for customer, right there, and then we fill car, print receipt, right, have that there, update inventory, right there, and then we go back and wait for the next customer, right? And we just keep repeating this every time, and we check for setup whether we want to go into setup mode. That's it. But this is an infinite loop, right there. Our pacemaker, that there. Wait. If during an interrupt, pulse heart, right there. And then we would say if air alarm, right there. Yeah, we just keep doing this right here, right? In other words, 60 times a minute, we send a little electrical pulse to my heart to keep it working. I don't have a pacemaker, but I know people that have pacemakers. And they're little boxes that are mounted inside their chest, and they have a couple wires that go to their heart, and they will do things such as monitor the heart rate, make sure it's going within a certain range. If the heart is going too fast, it will send some pulses to the heart to try to slow it down. If it's going too slow, it may try to speed it up. If it stops, it may try to shock it to start it. Right there. But it does various things. And you want it to just keep going around and doing the same thing over and over again. Right there. That's an embedded system. This particular programmer, I can tell, does not do embedded systems. Therefore, he spends a lot of time talking about avoiding infinite loops. And I'm just saying that in some cases we want an infinite loop right there. So he's got an example where we just go through and this program just runs and runs and runs forever until we hit control break in order to get to stop right there. And he just spends a little bit of time treating values as conditions right there. Right there. And right there. And this is just and this is kind of an interesting one that there is. Notice that in this particular case, we say if money, right there. Money is equal to integer input. How many dollars did you slip to Mater D? In other words, we're entering a value between that there. And our if statement just simply says if money. It doesn't say if money is greater than 10 or greater than 20. So it's looking just for a non-zero value for money right there. So in this particular case, this example right here, we gave him $20. This particular Mater D is stupid. If we gave him $1, that would be enough, right? Give him one ring and he's going to find you a table right there. In reality, if this was a fancy restaurant, you need at least 50 rings probably to get seated up there. But my Nasi Lemak stand doesn't require doesn't have a Mater D. You know, I don't go to places with Mater D's right there. That there. I've been to a few places that there, but a Mater D that there. And this is just simply saying that these two are the same. If money, we're just looking for a non-zero value right there. So creating infinite loops right there. Right there. So creating intentional infinite loops, he talks about that. Counts from 0, 1 to 10 is an intentional infinite loop. Finicky, he does like the number 5 and skips it, shows a run. This is not an infinite loop because right here, we put in these breaks right here. Right there. So it's just one of those cases right there where, skip the 5, yeah. But there, this particular program is kind of interesting, because we start off with 0, while true, right there, is we're going to, and that while true is kind of interesting right there. Plus equal 1. Oh, that while true, it just simply is the infinite loop right there. In other words, while true is the same thing as while hell hasn't froze over, or while it's hot in Malaysia. You know, it's always true right there. So while true, count plus equal 1, and then this break is what bails it out of that particular, you know, while loop. Without this break, it would stay in there forever. So the break bails it out of there. So this while this count really does do nothing. This is what gets us. If count is equal to 1 or 5, excuse me, this continue just tells it to go to the next loop around. Don't print out count, see count right there. So use the break to exit the loop right there. Use the continue to jump back to the top of the loop. Actually, this particular example would have been more interesting if this count was further up there. But there, to just show that when it sees continue, it goes back to the top of the loop. It skips the rest of the loop. In this particular case, the last statement, it does have one statement after that, and that's the print count. If it had 25 statements, it would skip all 25 statements right there. So it skips the next one right there. I think I'm still, I'm only a half hour in. I'll finish this chapter. So this is the break and the continue. I will be quite honest in saying that most people that are programmers and they're sticklers for format on programming, and they stress good programming techniques, do not like the break and continue. It's considered sloppy programming out there. So, out there. Yeah, you can use it. It's legal, but it's at there. You got that there. Again, he puts in there, but they should be used sparingly. That there. So it violates a single input and a single output. Format. And what he's saying is, in this particular case, the only thing we're skipping is the print statement. You could replace that with if count not equal 5, print count right there. And I'm sorry, I keep putting this semicolon at the end of that there. In other words, instead of using the break, or the continue, we can just simply say, if count is not equal to 5, print the value of count, right? Because that's the only thing we're skipping right there, right? Correct? We're only skipping that there. So why not just say, if count not equal 5, print count? That there. And we don't need an else for that there, because we're not going to do anything if count is equal to 5. So the continue is not needed right there. And the same thing with the while true, we could just simply say while count is equal to 10 right there. at there, and do away with this break right there. So in most cases, the break and continue can be eliminated very easily at there. So any loop you can write using them can be written without them. In Python, there are times when an intentional infinite group can be clearer than a traditional loop that there. So some programmers use intentional infinite loops. Now, I will point out that if we're writing code to be run in hardware, it is very, very common to write intentional infinite loops right there. Also, keep in mind that we're writing code that runs in hardware if our program ends what is going to be running on our hardware. Something's got to be run, right? Right there. So if you're writing you're designing I'm going to say a washing machine using a Raspberry Pi, right there. And you turn on that washing machine, or power up that washing machine, you want it to continue to do something, waiting for the start button or something until until it starts snowing in KL, right? And that there, that there. You want that washing machine to be ready for a command. You don't want to have to power it down and power it back up every time you want to use it. That there. Same thing with your refrigerator. And a lot of modern refrigerators have a lot of high-tech, microprocessor power going into it. I've seen some refrigerators that give the time and the weather and play radio stations. There, they connect to the internet. They have a little LCD display on the front of the refrigerator. That there. Again, that's something you would run with a Pi. That there, where the Pi, you can surf the web, check your Facebook page, then open the refrigerator to get your eggs out, right there. So, again, I'm just going to go through these slides right there. Username, this is right there. Username, Bill Gates, this is just a members club right there. The code for it. And again, here we've got a series of right there. Again, notice here that once we find Mike Dowson and the password is secret, he's got security level 5, we stop looking right there. So guessed right there. But again, that's just another example. This shows the else if right there. While not password. Password is equal to that there. So what's happening there is I can hit the enter key all I want. Password is equal to that there. And it'll just keep going there while not password. You're not so exclusive. Right there. Not a very impressive program right there. The not logic answer right there. Username is equal to empty string, while not username. Right there, true, false, right there. So again, this results in an empty string. Right there. So all it says is if you hit the enter key, it just returns an empty string. In US, the empty string is evaluated as false. Right there, which doesn't happen in C. C, if you hit the enter key right there, it'll put something in there. Here it just puts the empty string right there, while not username right there. And while not username. So the not is the Boolean operator. So it's looking for username to be something other than the empty string, and it's going to stay in this loop until it's something other than the empty string. So as long as I keep hitting the enter key, it's going to ignore it right there. So again, we've got here we're looking at the and right there. We're looking for the combination of username and password right there. And this is just giving me all the various possibilities. I'm not going to go through that there. The or, right here in this particular case, if the username is equal to guest or the password is equal to guest, we let the person in. Right there. So guest could be the password or the username. Right there. Again, these are very similar to that there. The major difference is that you don't necessarily need the parentheses around each one of these right here. Right there. You can just right there. And it's a simple or. C, you remember or was the two brackets right there. The and was the two ampersigns right there. So it's a little easier to read, I think. The or. Okay, planning your programs, I'm going to skip through that there. Creating with pseudocode. Pseudocode is writing your code in something that looks like English. I somewhat comment about that because you're Malaysian. Your primary language is Malay, right? So there would be nothing wrong with writing your pseudocode in Malay. Right there. Matter of fact, that would probably be preferable. Now, of course, if you submit it to me and ask me to help you, I will probably look at it like I'm not sure what you're saying. But the key thing is that writing pseudocode, it should be in the easiest language that you're thinking of. And this book is written with the idea that the reader is English or English speaking, not necessarily English. Could be American, Canadian, Australian, New Zealand, one of 100 different countries that speak English as the primary language, right there. So English would be the primary language you would jump into and start writing a set of instructions, right there. It's the same thing as pseudocode is kind of like the recipe for making a cake, right there. If I was to write a recipe for making a cake, I would probably jump in and start writing the recipe in English. If she was writing the recipe for writing a cake, she would probably write it in Malay. Any of you guys wanted to write a recipe for writing a cake, you'd probably give up. You probably never baked a cake, right? So, but regardless, when you deal with pseudocode, it's in the language that you're most comfortable working with. Because what pseudocode is trying to do is you're trying to develop the algorithm of what the program is supposed to do. And you shouldn't be fighting language while you're thinking about what your program is going to be doing right there. If I want you to replace the engine on my scooter, then I want to give you instructions that are easy for you to understand. I don't want to give you instructions in English and you don't understand English. You're liable to take my engine off and replace it with a sewing machine motor, right? That there, because you didn't follow didn't understand my instructions, right there. The problem you have is that languages such as Python and C and Pascal and Ada and all these other languages that they're based on English as their core language and the translation from algorithm to code is almost transparent. It can be that there. If you have the algorithm developed properly in your native language, then you can do the translation process then, right there. But that becomes just simply a translation. You already know that there. She already knows how to bake the cake. She's wrote the instructions in Malay, right? You know how to make this cake right there. So you want to give your American cousin over that never learned Malay, we'll say your brother moved to the U.S. when he was in college, and his kids grew up there. So you want to send them the recipe for nasi lemak, right there. You would write it down in Malay, and then you would translate it to English before you send it to them. But before you would translate it to English, you would write it down in Malay so you know what the recipe is. And that's the same thing with writing your algorithms out in Malay first, is you write how you're going to address the problems out how we understand. And then you go through the translation process to the Python code or C code or whatever. So he doesn't really get into this much because he talks about writing the instructions, and he's assuming that you're going to write them in English. You're going to have the same process of creating the algorithm in writing the pseudocode, but pick the language you think in. And that's really the key word I should use. You should write your pseudocode in the language that you think in. That there. I will probably live in Malaysia 30 more years, assuming that, that this, my plan of living here, retiring here, and this is now my home. I may live in Malaysia 20 years, 30 years. I may never think in Malay. I can't pronounce Malay clearly, so I don't speak Malay. That there. But for me to get to the process that I think in Malay, possibly will never happen. That there. Just like my wife, when she moved to the U.S., she lived in the U.S. for 7 years. She always thought in Malay. She never learned to think in English. I have an ex-wife that moved to the U.S. about 20 years ago, and she did not associate with Malays. She did not go out to dinner with Malaysians or out there. All of her friends were Americans. She worked at a hospital, or before that a pharmacy, before that a bank, but she always worked with Americans, never worked with Asians, right there. After about 5 to 10 years, her thought process switched to English. And to this day, she struggles to speak Malay. She was born and raised in Johor Bahru. Malay, lived in a compound right behind the mosque, that there. Never spoke English growing up, that there. But moved to the U.S. when she was in her middle 30s, and after 20 years, she can't hold a conversation very easily in Malay. Right there. So she came back to Malaysia, and she needed some documentation filled out to get her EPF money out, and she had to go to her secretary that she had when she worked here in order to get it translated, because she couldn't read the documentation. It was in Malay. She lost that ability. That there. So languages are very interesting things. That there. In her particular case, her primary language disappeared. That there. I don't think that'll ever happen to me. Now, who knows? Maybe 20 years from now, maybe I won't be able to speak English. Maybe I'll be speaking Malay 100%. That there. One of the reasons I speak English so much is because I work here, and I have to speak English here. And there's several of us in the office that don't speak Malay. Ibrahim doesn't speak very much Malay. He's learning. And Fadi doesn't speak Malay as well. So there's 3 of us that don't speak Malay in the office. That there. And what's her name? Lily, she speaks Indonesian, which is close enough to Malay. So everyone keeps telling me Indonesia is different, but I see people bounce in and out of Indonesia and Malay like easier than they do from Cantonese and KL discussion. Talking about language in Selangor to Kelantan is more different from what I can see than language from Selangor to Sumatra out there. Some words are different, but 90% of the language is the same, and the words are the same, and rules of pronunciation are the same. When you go from KL to Clanton, the rules of pronunciation change. And that makes it difficult to do. So, all right, enough on that discussion. So, stepwise, that there, and you can read that there. Guess my number game. I think I'm going to kind of write that there. This is just going through this particular program that there. Again, as I was saying, this particular book, and I assume everyone's got this book now, right? Yeah. It's actually a pretty good self-study guide. That there. I know that most people here don't like programming, but if you stick to this level and like this book, I think it's very doable. There. My goal is not to make you professional programmers anyway. Make you appreciate what programmers do and how they work. Right there. So that kind of wraps up this chapter. And our next chapter is loops, strings, tuples, and the word jumble game. Again, we'll fly through that on Monday. That there, and we'll probably come back and I'll give you an assignment on Monday. That there, I can tell you what the assignment is. It's going to be what I gave for the final project last year in the C programming course. That there, and that's the 10,000 games of craps. Right there. And what you should see when you play that there, I can tell you what you should see for the answer is that it's somewhere between 48 and 49% wins. Right there. And I'll talk about that on Monday. Right there. Please try to be here on Monday. If not, be sure you watch the video because I'm going to be assigning the next assignment that there. And I'm going to be gone for 2 weeks after Monday. So next Friday, no class. The following Monday and Friday, no class. So we're going to skip 3 classes right there. Next Friday, I get to go to I'm not sure what it is. My wife makes these social plans. And they're family oriented because everybody's going in the family. But I am not clear what it is, whether it's a nephew's wedding reception, or what. Usually it involves somebody getting married, but that there. Everyone gets married and they make that there. Marriages and babies are major events here, right?
Yeah.
That there. So in the U.S., when someone gets married, only close family get invited. That there. Here it seems like everybody goes to it. That there. So but regardless, next Thursday, Friday, there's something going on in Penang that's family related that I can't get out of. And then the following week I don't want to get out of, and that's my grandkids and son out there. In that case, it's my family, so it's important. That there. Well, I also keep in mind that I only see my children and grandchildren once a year normally, so I don't skip that, and I don't schedule when they can. They're coming according to my grandson's school vacation. That's how they're out there. So my school vacation doesn't come into play. They're traveling 3 times as far as I am, and spending 5 times as much money. So therefore they can pick the time that they're gonna go, and I just go. So with that said, we will stop this, and I'm up to my normal 50 minutes out there.